Broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Welcome to the Golden Gate chapters using Ingress and Leakage as a preventative maintenance tool. I think a lot of times we forget how beneficial leakage and ingress detection is. I'm Woody Cash. I'm the SCT Content Knowledge Officer for the Golden Gate chapter, and my contact information is wfcash@comcast.net. Should you have any questions about SCTE or Golden Gate chapter, by the way, we do have Cable Tech Expo starting just in about another week, so that's exciting news. And for those that were able to attend our Vendors Day in Concord, we had a fantastic Vendors Day. So with that, I'll go ahead and turn it over to Favlio. Favlio, would you take it from here?
Yes, absolutely.
Oh, I did forget to mention one thing to the audience. We do have some poll questions, so I'll be Flavio's got to pause, and we're going to ask the audience questions and give you a chance to engage in the training by answering the questions. So we'll display the questions so you can see what they are, and we'll show you the results of the poll. Hopefully we do well and everybody gets them all right, but we will try our best. Thank you.
All right.
And you should have rights to present your screen again.
Hang on. You're not seeing my screen now?
It's not coming up now.
Hang on. I didn't get the
Okay, let me try that again. Hold on one second.
get the presenter.
Okay, you should have gotten it. There we go. Okay, you're ready to go.
All right. Well, thank you very much. Also, hello, everyone. Good morning for most part of you out on the West Coast. I'd like to welcome you to this webinar presented by the SCT Golden Gate chapter. Today, we'll be discussing the relationship between ingress and egress detection and how it can be used in conjunction with a PNM solution to help network technicians more effectively resolve various network issues or impairments that have a direct impact on network performance and ultimately, of course, improve quality to subscriber services. So what we'll be doing today, we'll be taking a look at what exactly egress and ingress is and how they have an impact on network signals, okay? We'll also be talking about what is proactive network maintenance and how the benefits of it, of having such a system available to you in order to do your work, daily work, and upkeep of your cable plant. So let me first start by looking at what exactly, or a definition of what is egress and what is ingress. So egress, or commonly as we call it, leakage, okay, is when the RF signals, okay, from the cable TV plant, okay, are radiating or leaking out into the environment, okay. This obviously causes signal loss, okay, on the plant itself, okay, but it also has the potential of interfering, okay, okay, to what we're using in our closed network. Okay, happens when you have external noise, be it radio transmission, electrical noise, transients, okay, any unwanted noise, okay, that is in the air, okay, that is introduced into the cable plant, okay, due to a problem, okay, with the shielding effectiveness, okay, of the coax plant. Okay. Now, if you notice, I have I inserted the little green arrow, the bidirectional arrow, okay? So what's this, I'm meant to indicate with this, okay, is in cases, or most of the time, okay, in cases where you do have a leakage or egress, okay, at a given frequency, okay, you'll also, unfortunately, be getting ingress at that same frequency, okay? So that's a very important point to always remember, okay? And reasons why a lot of, cable operators obviously do leakage detection, okay, in order to resolve any, cable problems on the plant itself, okay? Because that leakage, okay, when it leaks, other than interfering with, other services, or may interfere with other services, okay, also has an impact, okay, on the plant itself by also having ingress, okay, come into the plant itself. Now, in this next slide, okay, I use an example that I always like to use this because it's very pertinent, okay. What you're looking at here is what we call a leaky feeder coax cable. Now, this type of cable, it's a coaxial cable, although it is 50 ohms and not 75 ohms. Okay, this type of cable is intended for use in applications such as mining or tunnels, okay, or like subways, for example, okay, to allow allow for two-way radio communication, okay, within that environment, okay. So on the slide, if you can tell on the coax cable, you'll see that on the shield, okay, there are some holes or some apertures, okay. Well, these apertures are actually tuned, okay, apertures to a specific frequency band, okay. So the use of this, okay, is in order to send a radio signal along the coax cable, okay, and at given frequencies, okay, it will voluntarily leak in order to broadcast the signal, okay, within the environment. Now, since it's a two-way radio communication, okay, the ingress portion, or the signal coming into the plant, okay, is at a very close or similar frequency, okay, proving the point, okay, that you can in fact use a cable, a coaxial cable, okay, to have voluntary egress or leakage and ingress at that same frequency, okay. So in our case, okay, when we have a break in the shielding or a defect in the shielding of the cable, okay, this is where there is leakage, okay, and except the only problem is we don't know, okay, or we can't know for sure at what frequency it'll be most evident, okay. And of course, okay, since there is egress at that given frequency, okay, there'll also be ingress at that given frequency. So correlation in frequency is a very important factor, okay? We talk a lot about frequencies and where it happens, okay? So when you have breaks in the shield, you'll have leakage and ingress, okay, at various frequencies. However, we're typically doing leakage detection first and foremost in the aeronautical band, because we have to abide by FCC rulings, okay, but also to maintain the plant, okay. But as you can see, okay, there is very little correlation in frequencies, okay, when you're doing both, leakage detection in the aeronautical band, okay, and leakage detection in the upper frequencies or UHF band, okay. So one good example here, okay, a proven fact, okay, is there was a leak found at 137 megahertz, okay, which was barely 10 microvolts per meter, which in the majority of the cases, okay, in our industry, we would not even bother looking at a 10 microvolt per meter leak, okay. However, that same and there's various reasons why it is intermittent. Could be, due to temperature, could be due to wind, humidity, various impacts, okay, could cause ingress, okay, to be intermittent. The actual physical problem is always there, except it is the source, okay, of the noise, the various noise that causes ingress, okay, that is intermittent. Let me show you some various examples, okay, of ingress, okay. So as I said before, okay, you're seeing here on these pictures, different pictures, okay, these are different types of the defects in the coaxial plant, okay, that impacts the shielding integrity of the coax plant, okay. Obviously, these things can happen in the subscribers' homes, okay, but often, okay, you also encounter problems like this in the outside plant, okay. As I mentioned before, a rodent chew, okay, that is very common, okay. But you're also seeing there what looks like, or not what looks like, what is a bent or kinked cable, okay. So the bent cable or kinked, okay, cause the dielectric, okay, and the shield, okay, to be, damaged or squeezed or impaired, okay. And this, okay, becomes a very good source, okay, of ingress to penetrate the plant, okay. Now, these examples here, okay, is important to note, okay. Then in all these cases here, okay, we were able to find, okay, the problem, okay, being ingress, okay. However, okay, none of these issues here, okay, were detectable using a leakage detection system. Now, this is not to say there was no egress. There was definitely some egress there. All right, but in conventional patrolling or seeking out, detecting egress, okay, these faults, okay, or these problems did not pop up as a leakage problem, okay. There was egress. If you would bring your leakage detector up close to these defects here, you would definitely record a certain level of egress as well.
Flavio, I'm back. I don't know if you can you hear me?
Yes, absolutely.
Okay. On the rodent chew, one thing of note, it was some of my experiences that often rodents would tend to, at least on hardline, would chew a trough in the top of the cable coax.
Mm-hmm.
And if you went up to the strand and measured above the strand, the leakage was very high, and if you went down to the ground, you'd almost detect no leakage.
Yeah.
So yes, yeah, but I'm sure there was egress getting in. That might have been before we actually had two-way plant. But yeah, there's a lot of factors in how egress propagates from the coax cable itself.
Correct.
And Jonathan put in the questions section, he wanted the answers to our polls. Were you able to answer those, Flavio?
No, we didn't get to the answer portion of the poll, so I don't know how we made out.
Oh yeah, you didn't. For some reason, the presenter doesn't see them. I'm not sure why, but if you wouldn't mind going through when you have a chance here, go through the first three questions and answer them.
Sure, let's do that now. Let me back up here.
Okay.
Excuse me. All right. So the first question was, CLI figure required by FCC is 64. Okay, for a frequency band of 54 to 216 megahertz. Okay, which encompasses the aeronautical band. So what is the passing CLI figure for the frequencies above 260 megahertz. So the choices were 62.8, 58, and 68.
So I found out how I can share. So just FYI,
Yep.
20% of the audience answered 62.8, 50% answered 60, and 20% answered 68.
All right. So the right answer is 62.8.
Yeah, which is a strange number. So I'm wondering
Yeah,
how that came up with that. I guess it's relative power.
exactly. Yeah. All right. So second question was fixing aeronautical band leaks and to meet CLI will completely harden the cable plant. Is that true or false? And the answer obviously is false. All right. As I mentioned before, performing only aeronautical band leakage detection, okay, will not allow you to see all the problems, okay, that are impacting the hardening of your cable plant.
Yes,
All right.
unfortunately, I lost the ability. Oh, I have the. No, I don't. I lost the ability on the control window to do the. Let me try this. Let me get out of here. Show poll results. Okay.
Yeah, it's a little window. Yeah.
Let me try the last one. Let me, if I hide this. Yeah. Okay. So now, what is the minimum leakage level for calculating CLI? I don't know if you answered that or not, but looked like 80% put 20 microvolts per meter, and 20% 50, and 0% 100.
Okay, so the correct answer is 50 microvolts. Remember, this is the leakage level to calculate the CLI, not the level required to perform repairs, which is typically, as a rule of thumb in the industry, 20 microvolts. But for calculation of CLI, it is 50 microvolts.
Yes. Yeah, because so many of us were fixing leaks down to 20. So we automatically think 20. So if you're been in the field and you fix leaks, you think 20 because you're stopping and fixing everything above 20. But when a flyover is done, or if you manually calculate, which not too many people do anymore or ever did, as far as I know, you only count the ones that are 50 and over.
Correct.
But it's a good idea to fix everything you can down to 20.
Absolutely, absolutely.
All right, so we can go back to where we were, and sorry for the interruption, everybody.
Sure, not a problem, no problem at all. All right, I think we were at the second portion of the Q&A, right?
Yes. Oh,
all right.
Let's see. I don't know where we left off. I apologize, but I don't.
All right. Yeah, we were here on this slide here explaining the different sources of ingress yes. rather, okay. And the examples they're showing, that these are all, they were severe enough ingress problems, okay, but they were not being detected at all with any leakage detection equipment. So this brought us to the second portion of the Q&A. Of course, this it's relating to ingress, okay? So first question, okay, what is an expression that we use for accumulation of noise at a node? So the selection was or is A, clipping, B, saturation, and C, funneling.
Okay, so we are getting some responses.
Okay. Should I go on with the other ones, or should we wait for?
No, let's wait. 44% voted, so we'll give it just another minute.
Sure.
So far, usually about 63% of the attendees are voting, so I take it the others are not bothering, but we're up to 56%. I'll give it just another minute here.
Mm-hmm.
Okay, we're stuck at 56%, so I'm going to close the poll and let me see if I can display it. Here we go. So looks like 0% called it answered clipping, 20% answered saturation, and 80% answered funneling.
Excellent. So the answer is funneling. So 80% of you are correct.
Okay, and let's
All right.
see, we have another one, don't we?
Yep. A second question here, very simple. A break in the coaxial plan caused a leak. Will it also cause ingress? True or false?
Okay, I need to launch the question, so hang on a second. It's a little bit tricky. And let me launch. So the true and false question, everybody, so it should be fairly easy to answer. So 11% have voted. Give it another minute here. Okay, we've got up to 67%. I'm going to go ahead and close the poll, and then I will display the answers. Okay, so 83% answered true, 17% answered false.
All right, and the answer is true.
Yeah,
always be.
And I don't think everybody realizes that, but it actually does. But sometimes it's, you know, one is minute and one is large.
Exactly.
Yeah. So, exactly. Yeah, there's always two-way traffic on any kind of integrity problem or two-way interference. So, yeah, a lot of folks don't understand that just because when you fix leaks, sometimes you'll detect a big leak, you won't see the ingress anywhere, and you think, okay, well, there's no ingress, but there might not be anything transmitting at that location at that time, so you may not see it.
You may not see it.
Okay, is that our last question?
All right. No, it was one more. Okay. So the question is, what is a distinct characteristic of ingress when hunting it down? Okay. So A is intermittent, B propagates and travels on the strand, C it's multidirectional, and D all of the above.
So let's see, 11% have voted. Stick with it for another minute here. I take it everybody's thinking about this one. So we're up to 67%. That's as high as we've gotten so far. So I'm going to close and display this. Let's see here, share. And so we have 0% intermittent, 17% answer propagates and travels on the strand, 0% multi-directional, and 83% put all of the above.
And the correct answer is all of the above. Okay, these are all characteristics, okay, that you know are evident, okay, when chasing down an ingress or a source of ingress.
Yes, and if you have intermittent ingress, so one thing you don't want to do is leave leakage out there, or you don't want to drive by any leakage, because any one of those leakages could be the source of your intermittent ingress, because again, ingress isn't there all the time, so you don't know when it's going to come, and you certainly want to make sure your plant is tight as possible to try to alleviate those intermittent problems.
Correct. The physical problem itself, okay, is always there, except the noise or source of the noise may be intermittent and not be there all the time for whatever reason.
So thank you, everybody. That ends our polling questions, but we can get on with the rest of the presentation.
Okay, so we'll continue on, And now we're going to talk about PNM. Okay, so what is PNM? Well, essentially proactive network maintenance. So what it stands for. It's a philosophy in essence. Okay, that was determined for determining the plant issues. Okay, or finding problems with the plant. Okay, before there is any impact to customers. Okay. So this was brought in by a working group at Cable Labs back in 2009. Okay, and I believe at the same period of time when DOCSIS 3 was introduced to the market, and this was rendered it possible, okay, to leverage information, okay, that was captured, okay, from the customer premise equipment. Okay. So there's various data sets or metrics, okay, that were being used or being used, okay, to apply to a PNM solution. So obviously the ability to do pre-equalization measurements in the upstream, you know, looking for micro reflections, group delays, okay, the capabilities going forward with DOCSIS 3 of being able to do a full band capture of the spectrum, okay. Of course, we add in there egress, ingress data, okay, and any other data sets, okay, that are, you know, became available over time, okay, with the introduction of new technologies, okay. This all contributed to, you know, a means, okay, of capturing this equipment, these metrics rather, okay, to be used to, you know, determine or analyze, okay, the problems that are being subject onto the plant, okay. In the future, as we go on now with the introduction of AI, okay, there is, you know, lots of correlations can be done, okay, to identify potential network impairments. So not network impairments are there presently, but potential network impairments. So various ways, okay, for this is data visualization, sorry, okay, where you're able to see all the data sets onto an application, from an application, including egress and ingress, okay, to facilitate, okay, the proactive maintenance planning of the plant, okay. This also provides a means, okay, to properly and effectively, okay, allocate resources, okay, to do the maintenance, okay, of these of the plant, okay, in order to be again proactive, okay. In the long run, of course, continuously doing this type of maintenance, okay, it'll optimize the performance of the network, okay. Being able to, you know, foresee, if you want to say, foresee problems, okay, that could become major and impact the customer before the customer advises you, okay, that there is problem, that he's having problems with the system. So the representation, basically a basic representation, okay, of, you know, how PNM can be used, okay. So of course the main element, okay, that can be used is the subscribers themselves, okay. With the cable modems, okay, that are in the homes, okay, the system can pull and can interact with the modems, okay, to obtain, you know, different data sets, okay, that are indicating, okay, potential problem in the upstream or the downstream, okay. Now, at the same time, okay, within the network itself, as you're doing ingress and egress monitoring, okay, this adds to, okay, the results that are being captured, okay, by the system, by the monitoring system, okay. So and effectively what this allows you to do, it allows you to correlate, okay, the problems that are being monitored and detected, okay, from the subscriber's premise equipment, and any other element data set that's coming from the plant itself, okay. For example, transponders, okay, that are in the power supplies as well, okay, in conjunction with the data that is available indicating where there is egress and or ingress problems, okay. So this becomes, you know, a conglomerate of information, okay, that can really allow you to pinpoint, okay, where to send your maintenance technicians, okay, to effect the necessary repairs. So how does PNM help find your problems? Well, transient issues like, okay, or intermittence, okay, this is also involves intermittent problems, okay, could have different impacts at different time of the day, okay, could depend on temperature, it can depend on other types of environments such as wind, rain, etc., okay. So there's an unprecedented amount of information, okay, that is being accumulated, okay, to allow you to analyze the state of the network, okay. Of course, this is always gives the technicians, okay, additional tools, okay, and information in order to help them solve and pinpoint and solve the problems, you know, that are present on the system. Okay, this is also a means where you can, you know, you can allow your customer service agents, okay, to themselves, okay, with the information given to them, okay, provide, okay, service requests, okay, so the problem could be looked at, okay, before it starts impacting the subscribers themselves. Now, how is all this data consolidated? Okay, well, there is Cable Lab also came up with back then, okay, for PNM, they come up with this platform called a Common Collection Framework. Okay, so essentially what this is, okay, these are Python modules, okay, it's software, okay, that work together, okay, to allow, okay, the network to be polled, okay, to be interrogated, okay, and using SNMP managed requests, okay. So the actual PNM data can be requested, okay, by this framework, okay, in order to accumulate data, okay, that will be used, okay. It's very simple. It's not anything complicated, okay. All it is a common source, okay, or common means, okay, of providing network data, okay, to different applications that may be used, okay, to create this this environment, okay, of doing preventive or proactive maintenance. Okay, so what this allows also to do, okay, is to, for example, use, you know, some custom built software application or web applications, okay, where all this data could be visualized, okay, and can be analyzed, okay, in order to provide, you know, an output, okay, giving the service groups, if you want, okay, the means to go out, okay, and actually quickly, okay, and effectively repair the problems, okay, that are on the network. And then next slide, I'm showing you a couple of examples of different, you know, software applications, okay, that were built, okay, using data from PNM, from Ingress, in order, again, to correlate, okay, the source of where the problems are coming from. Now, remember, when we were just using the the cable modems example from the customers, okay, this allows, for example, the problem to be isolated to a certain sector, okay, but you can't really know where the actual problem is, okay. But if you correlate that data with the data from your egress and ingress detection, okay, then you're able to more closely pinpoint, okay, where the problem is likely to be, okay, and then know, and therefore be able to react on it immediately by sending out service crews to repair and resolve the problem. Okay, so this PNM workflow, along with these type of application, okay, is becoming a very, very valuable tool, okay, in order to be ahead of the game, okay, in keeping your maintenance, your network maintained and operating optimally. So by integrating all these data sets, including ingress and leakage, okay, you're able to, you can be able to do, scheduled testing, okay, to make sure that the different areas of the plant, okay, are consistently being monitored and repaired, okay, as need be, okay. It gives you also a way to use all the data available to analyze, okay, what's being collected from the plant, okay, and be able to, react on it, okay, spontaneously. Therefore, giving the ability to have corrective actions put into place in an effective manner, okay. And of course, by doing this continuously, okay, in the longer run, okay, the network performance, okay, will always be, optimal as much as possible. So in conclusion, what does all this give us? Well, it gives us, one, of course, improved plant integrity, okay, and ultimately always an enhanced experience for subscribers, which is the the bread and butter of the revenues, okay, that cable operators use, okay. It reduces maintenance costs because by having all this information available, okay, you're able to send out service crews, okay, and repair the problem immediately, okay, as opposed to not having the accurate information and therefore requiring you to send out several times, okay, a maintenance technician, okay, to perform or look for the problem itself. Of course, network reliability will be increased, okay, as this is being done in an ongoing fashion. And ultimately, okay, it always comes down to an enhanced customer satisfaction and a happy customer. Always remember, it's easier to maintain a customer than to gain a new customer. All right. So this wraps up the presentation. Leaving the floor open if there's any questions or comments that need to be and want to be raised.
Folks, you can
open the floor.
Type your questions in the questions box. And if I might take this opportunity to ask the audience a question. So there are two things regarding signal quality that fixing a leakage and or ingress issue. What are two other improvements to signal quality would happen if you were to fix a problem like that? I'll give the audience a second to answer.
Sure.
So we already know that ingress, if you fix egress, you'll fix ingress, and vice versa. But there's another couple of signal quality issues that making a repair will actually resolve. So I'm not seeing any answers. So two things, and most of you guys have, most of the technicians in the field probably have experienced this. One is it improves attenuation. So if you
Mm-hmm.
have you know, a rodent chewed cable and you replace it, and a lot of times what we do is, you know, a person fixing leakage ingress may not be going measuring signal level, and they may not realize this, but your signal level improved when you fix that rodent chew. Um, Same thing if you have a fitting on a drop and a little bit of water got in it, and you have, you know, maybe an inch or two of corroded drop cable, and now you cut it back and put a new fitting on it. You'll see the level into that customer end device actually improve. There's
Mm-hmm.
one other thing. And many people may not realize this, but it'll also improve distortion. People don't realize that. So you have signal distortion anytime you have plant integrity or drop integrity issues. So by cleaning these up, you'll actually improve the signal distortion. And by the way, that was quite neat how operators are integrating the leakage tools with the P&M tools.
Yeah,
Uh,
absolutely.
there was one thing we didn't talk about. I think it's a little futuristic, but it is coming. With the DOCSIS 4.0 modem, we're able to put a tagger on the modem transmission, so our gear in the field will actually detect that. So the caveat though is you can only do that with DOCSIS 4.0 modem. So right now you can't do it, but it is coming, and as those get more integrated into our network, the ability to utilize utilize that tagging to find ingress on the reverse. I think that's going to be profound. I think that's going to be a very useful tool.
Yeah, and by that I think you're referring to OUDP,
Yes,
leakage detection. Yeah,
I forgot the
absolutely.
acronym, but OUDP is coming. Uh, I, it would be really cool if the software that the technicians use to identify problems can allow you to toggle it on and off, so you can actually
Absolutely.
use
Yeah,
that as a process of elimination and get to your problem faster. But that's the goal, right? To utilize the software and all the tools we have to
exactly. Yeah,
get to that problem. And last, I'll say, you know, if you fix all the leakage and ingress on your plant, of course you'll still see issues in P&M. And if
sure.
you fix all the P&M issues, you'll still see ingress and leakage. So there's no silver bullet. You just have to utilize all the tools available.
Available to you.
All
In
right.
case no one knows what OUDP stands for, it's OFDM, upstream data packets.
Oh, thank you. And again, that's going to be a real cool tool, but we're a little ways down the road. We did get a question from Jonathan. As someone who has dealt with signal leakage for over 45 years, I appreciate this presentation. My favorite photo is of Steve Allen shot of a beer can wrapped around a trunk as a quick leak stopper before the span could be replaced. I miss Ted Hartson, aka Dr. Strange Leak. so yeah, we have seen some. For those guys who've been around a long time, we have seen some you know, a lot of bizarre temporary leak fixes out there. I haven't heard of the beer can one, so thank you, Jonathan. That's new to me. Appreciate that.
Well, I can tell you, I've seen a coax cable splice using electrical Marets.
Oh, okay. I haven't seen that one either. I think what a lot of folks did in my early days is they just took aluminum foil and electrical tape and would
Oh yeah,
run it around the cracked cable and you know, until they could get back and put splices in and cut that section of cable out. But Yeah, there's some very creative ways to temporarily fix leakage and ingress. So I just want to thank the audience for joining. Hopefully you enjoyed this. I apologize for the audio problems, and I hope that wasn't too disruptive. And I'm looking forward to our next webinar. Oh, and I want to mention or promote something we're doing in the first week of December. I believe our turn is December, the week of December 2nd. All the California chapters will be hosting different webinars at different times for 4 straight days, Monday through Thursday. So all 4 chapters, and ours are going. The Golden Gate chapters is primarily on preventive maintenance and P&M. So we will have an expert talk about P&M. And then we also have like virtual CMTS and optical fiber topics that we'll be presenting, and you'll be seeing those flyers soon. Look forward to a lot of you folks rejoining us for that. So thank you, everyone. Have a wonderful day, and we'll talk to you again soon. And thank you,
All right,
Favlio, for the presentation.
Yep. Absolutely. Thank you very much all for attending.